Okay, so we're going to work on the autofocuser for my telescope, but we're going to use an Arduino Nano and a constant or continuous motion servo. So this is MG996R, and the links to the description of all this stuff is down below. The way I designed this is this is going to be our calibrator. It's going to find our dead banding. It's going to give us our slowest movements we can do, and then it's going to do some ramping, and then we can also go into manual mode. And this can be freestanding. So right now it's not hooked into the computer. If you hook this in the computer, your servo's not working well. You need to have a powered hub, because this does draw quite a bit of low current when it starts working. So I'm gonna go ahead and get this plugged in. Let's go over to the computer here and show you what's going on over there. So now on the computer, here's the application that I have. You'll be able to download this application in the description down below. I'm going to walk you through briefly this. This is digital pin 9, digital pin 5, digital pin 3, or 2, and digital pin 3. So this big step is how much it jumps in this configuration, right? If you want it to go longer, you can. I don't like waiting on it, so if you want to play with it, you can play with it. And your smallest step should be 1, because we want the smallest, finest search we can get, right? And we also want to find it fast. We don't want to sit here forever. So our calibration stop point is this number here, and this is the theoretical. Our calibrator will find the actual middle of the dead band, and it will set it to that. My tests are going to repeat, say 15 times. So for brevity, we'll make it 10. Current step delay, this is how long the motor runs for. I want it to run the minimum, and that's 100 milliseconds. So that's 0.1 hundredth of a second is what that is. So instead of flashing an LED, I'm just beeping the buzzer, right? So if you look on the screen here, you'll see that there's the Arduino up there, and so you can kind of follow along with the pin numbers, and you can see them up top, like D9's 27 there, the yellow line. It's a signal pin. The LED pin, which is a buzzer, it's on D5. That's like, I don't know what, 23. And then you can see D3 is the red wire, and then D2 is the brown wire. And then you can see the two buttons, they both go to ground, which is the yellow wires on the opposite side going to ground. And then you can see BN goes to the 5-volt rail. Don't put anything more than 5 volts into this, you'll fry both. Well, you kind of really won't fry the Arduino. It goes up to, I think, 7 or 9 volts. I don't remember exactly, but you gotta be careful on the inputs. And then the ground, ignore 20 through 27, that's nothing. And then on the other side, you'll see that the white wire there at the top is going to the servo motor. That's the ground line. And then I have a capacitor, which is this 10 microfarad. You can use whatever value you want. It's just for the motor. And then the orange wire is the 5 volt. So, getting back to the application here, I'm going to go ahead and turn this off so it's not distracting, right? You can repeat the tests 10 times. You can change these numbers. The manual twitch, so this is when you go into manual mode and you're using the buttons in manual mode. This is how fast the buttons will work, right? Or how long the motor will run when you press the button. And then the step will be is what you calibrate it at. So you're getting the finest tuned movement. The debug, you're getting a debug. I did a digital debug on here, or digital, not debug, digital debouncer. So you won't get like double inputs or triple inputs or something like that. So 150 milliseconds, pretty good. And then the serial timeout. After 10 seconds, if there's nothing in the serial port, it automatically exits calibration mode, goes into manual mode. Oh, it's just start time. So this is just for all the servo testing stuff. Like I say, you can get all the code is all down below. So let's go ahead and get this thing plugged in and run the calibration steps on it. So I'll go back over to the. You guys will get picture in the picture, but I gotta rotate. Oh, we are plugged in. Okay, so we are plugged in. So since we're plugged in, all I have to do to run into calibration is just open the serial port console, and it should reset it. And I think I'll leave this here. I'm going to rerun the calibration, so I'm going to say yes. So now it's going to ask me, you can hear it beeping, right? Every time it's trying to make a move, it's going to beep and it's going to flash the LED. So I have to watch it. No, it didn't move. Nope. Didn't move. Oh, wait, let me go put the toothpick on it. So we'll put the toothpick on here. Oh, I can't grab this toothpick. It just makes it easier for everybody to see it moving, right? And I can hear the motor grind. And when it gets close to its deadband zones, it will, it'll mutter. So you see it's fully moving there. So we want to make sure it's not skipping any steps. That looks pretty good. So I will say yes to that. Now you'll see it's ramping down now. See, we just jumped 15 microseconds. We're trying to find the slowest speed our motor properly works at. So we're going to say yes, it's running on that. I would suggest you let the motor run for a little bit until it does that. That means no. It's buzzing, but it's not moving. So that means you've hit the lowest point. So, no. Now we're going to go the other direction because it is different. So that looks good for that. Nope, not moving there. So now it's going to ask you if you want to save the calibration. There's our calibrations, and now we're going to do some stepping. So you see right here, it's not moving. Now it picks up back moving. So what you want to do is you want to rerun the calibration and do one step before. Same way with this one, right? Or maybe that's the same one. I wasn't paying attention. Yeah, so that one there. That's 1544 is not working properly, is it? Yeah, 1544 is not working properly. So 1425 is working properly, right? So what we can do is we'll just stop this. We'll reopen the console. It'll re-go through the calibration steps. We'll say yes. And then you just run it again, right? You know. We'll say no to that. And we'll just say no there, right? So now we'll save that to memory. Now we'll watch it run, right? It's barely moving. Looks like it's missing a lot of steps. Yeah. We don't like 1426 either, right? So we'll say no, we don't want to do 1426. We'll come back, we'll just rerun it again. We'll just stop her there, right? Now we'll let her run her tests. Oh, yeah. Still skipping. That's alright. So you guys getting the idea of what we're doing here, right? So what I want to do is I'm going to show you another thing. So if I was to unplug this, and then we put say, you know, because if you see my power supply series, I'm going to put this back in, and this is what's going to drive. This is my MIC 29510-5. It's a 5-volt regulator. It does 5 amps, and I will put this in to drive this motor, which is my autofocus on my telescope. It will also run some fans and the power supply. I will redo the power supply video again with the new updates, and this will be in there for this motor when I do this motor and I set the motor up. So it'll all this is coming in the future. We're gonna run this off my power supply back here, so I'm just gonna put this on the negative rail. We'll put this one on the positive rail, and we're gonna turn this on 5 volts. So now we're running 5 volts through there, right? So it's gonna run through the calibration procedure even though there's nothing in there. You'll see it flash. Now we're in manual mode because there's no calibration that had been done, so now you can actually try your buttons. So you see this actually works for this button, and this works for this button. Sometimes intermittently it looks like, right? But you can go back and run your calibration. So the whole idea of this thing is we can find the deadband exactly. We can find where we have the intermittent area, and we could just override it by having it telling us that stuff, right? It's a little bit harder for me because I'm running back and forth. I don't know what the motor's doing. I can't see it when I'm over on the computer here. But I'm going to run this again. I'm just going to set up a little bit differently. As soon as it starts running, so I'm just going to say no. I'm making big steps. No, I'm going to say no. I'm going to save that to permanently memory, and we're going to run the calibration. This way I know this all works, right? So this is going to go for about 500 milliseconds. And then I'll just kind of let you guys watch this thing for a little bit. Like I said, everything for all this stuff to get and get working will be in the description down below. The telescope autofocuser is coming up. And then the power supply stuff, working on the power supply for this, is also coming up. Alright, So, I don't want to keep this going. I don't want to have a long video for this, but you get the gist of what's going on. All we controlling is the speed the motor moves and the amount of time that the motor moves, and you can see that in this whole movement, right? So it's moving slower. Look, it's moving the same slow speed. It's just moving for a longer duration. And then before, you remember earlier, it was going right. It was running for 100 milliseconds. So now we're up to, I don't know, what's it, 300? Yeah. So 375 milliseconds. Not even quite a half a second yet. It's running, right? So anyhow, if you got any questions, post them below. Subscribe, follow, hit the bell. You'll see what's going on when I update this stuff. You'll get notified. You'll be able to keep track of this. You can also, even, I'm going to get out of that and wait till the light flashes again. And we'll just go run this manually, right? And we have an autofocus so that we can manually control remotely without touching the telescope. It's gonna be so awesome. I can't wait. It's gonna be so cool. Alrighty, so anyhow, you got the whole gist of that. I will see you all later.